So I'm going to switch my webcam off and mute my microphone, but I'm here. Rick is here. If we need to communicate anything to each other, we can do it through the chat window here in Blue Jeans. That of course won't be broadcast at all.
Good morning, Lakota.
Hello and welcome to the final session of the GEO 2020 week. I could say good morning, good afternoon, or good night, wherever you are. And I'm very happy to chair this final session on open data and open data policies. We have 4 very exciting presentations in this session. I am Werner Kutsch. I'm the Director General of the Integrated Carbon Observation System. The Integrated Carbon Observation System is a European so-called research infrastructure, a distributed research infrastructure over many European countries, and we have spanned a network of greenhouse gas observations over many countries in at the European continent. We have recently calculated that we are covering about 43% of the area of Europe and Greenland, and we are very open in our data policy. All the data we are measuring are fully available, open and free at the ICOS so-called carbon portal. You can download them there, and you can get access also to computing power to analyze the data. That's perhaps the reason why I was asked to chair this session, because we have this broad experience in the open data, but we are also a participating organization in GEO since 2016. Well, this session is, as I said, about open data. The general objective of this session is to discuss approaches to open data, expanding access to in situ data and analysis ready data for continued integration in the digital economy and sustainable development, including the experience from GEO Initiatives and Flagships. This is in support to the Article 9 of the Canberra Declaration, in which the ministers reiterate the critical role of full, secure and open sharing of Earth observation data and knowledge will play in deeper integration of Earth observation technologies into the digital economy. So they want to encourage the governments to increase free access to Earth observation created using public resources. So again, welcome to this session, and the first speaker in this session is James Redling-Leaf Sr., who has over 25 years working experience with the US federal government, higher education institutes and non-profits to develop and maintain effective working relationship with federal and non-federally recognized American Indian tribes, tribal colleges and universities, and tribal communities. James is a founding member of the group of Earth Observation Indigenous Alliance that was established during the GEO Week in 2019 at Canberra to foster a continued, effective, respectful and reciprocal relationship with GEO and representatives of indigenous communities from all around the world. He was born on the Pine Ridge Indian Reservation and is an enrolled member of the Rosebud Sioux tribe. James, the floor is yours.
Well, thank you, Warner. And I want to begin by greeting the GEO global community in a good way. In my culture, we begin by saying, "How midakuyapi, tante washted nape chizapalo, James Redling-Leaf imachapi na shichangula kota oyate." I'm coming to you today from Chesapa, the Black Hills of South Dakota, USA. And it's my great opportunity and privilege to be with you today and to share some of the experiences that I've had, but also really providing maybe a pathway forward in terms of how we work more effectively with Indigenous people around the world. And so my title is Every Tribal Nation Has a Data Story, Challenges and Opportunities Moving Forward. Next. So as Warner mentioned, I was part of a founding group of Indigenous leaders who came together last year at Canberra, 2019. And so we, at the invitation of the GEO community and GEO leadership, we got to talk and present our programs, our issues, and also begin to explore opportunities of how GEO can work more effectively with Indigenous people. In that time together for that week together in Canberra, we came around the table with our partners to talk about what can be done. What is the opportunity here really to bring our voices together in unity through diversity to address our real issues in our Indigenous communities using geo science and data and technology. So together we came up with this vision, protect and sustain Indigenous cultural heritage, utilizing and contributing to global Earth observation, science, data, and technology. And so the picture you see in front of you is representatives that we are working together. This past year we've been gathering, we've been talking, and we've been making decisions about how it's best that we go forward in a partnership with GEO. So we are grateful for leaders like Stephen Ramage at GEO. Gilberto was also very supportive in putting together this group to really begin to think deeply about how this could work together. Next. So in our planning, we this past year we came up with these strategic pathways. I think it's really important that we do these things, and so we really understand that in our changing environment and changing world, we know that Indigenous knowledge is an important part of going forward. So we needed to think about how we work with our knowledge holders, our elders, to transfer that knowledge to our younger people. We think that partnerships are going to be a part of that, to do that. We also think that in preparing a future workforce to use geoscience, data technology. And so how we do that, how do we build a curriculum to prepare our young people to going into this area? Again, as Indigenous people, we know that it's important that we continue to strengthen who we are. So we use the word cultural heritage to help define that work, that opportunity. And so that's our languages, that's our lands, that's our way of life, that's our spirituality. And finally, we thought that it's important that we contribute to GEO, the Group Earth on Observations, and so that we provide a forum to consult with us and also other Indigenous people around the world when we talk about new opportunities. So that's our strategic pathways. Those are things that can help build the foundation, a framework for our work going forward. Next. So I was asked to talk about the issue of sharing our open data, and so I wanted to really talk about it from the past in terms of how Indigenous people, at least from my perspective, what we need to think about as a community. So in the past, a lot of these data efforts were really led by non-Indigenous groups. Those groups really control the data collection, use, dissemination, and ownership. I think they also lacked the relationality with Indigenous communities, Indigenous nations. They really did not include tribal or Indigenous values, protocols, or worldviews. So, in doing this work, I think it was very challenging in a way. And so we recognize that. We recognize that this idea of working together is very important. And there's no FPIC. So FPIC is an acronym, right? Free, prior, informed consent. There was no really recognition of the rights of Indigenous people when doing this work with data. We also believe that the data quality was an issue. I think it was really not addressing, again, the priorities of our tribes in terms of working in science, working in research, and those kind of things. So these things are important. And I think that understanding the past helps create a context for understanding going forward. So that's how we see it in terms of what's happened in the past, but also how we can think about it in the future. Next. So this all work led to something called Indigenous data sovereignty. I think this is a very key emerging application. So we say Indigenous data sovereignty supports Indigenous sovereignty and self-determination, reflecting the needs and priorities of Indigenous people. Indigenous nations data includes facts, knowledge, or information about the nation and its citizens, lands, resources, programs, and communities. Data collection reflects Indigenous perspective, worldviews, ethics, values, and protocols. The inherent right and jurisdiction of each Indigenous nation to control the collection, ownership, and application of its data. And finally, we say data are subject to the tribes or to the Indigenous nations' laws and governance structures. More and more NGOs around the world are addressing, wrestling with, tackling this whole idea of data and how it fits in with Indigenous people. So this is really a really broad definition, but I think it's important that we begin to recognize these things. I think it's important that we begin to understand what this comes from, and it's important that wherever we go forward, how we go forward, it's going to have to be done in partnership. Next. So in America, where I'm from, I think that the perspective that we say is that when we think about data, we think about Indigenous people ourselves. We memorize our information about our families, our tribal membership, and history, and natural resources. So we had they call it oral history, oral tradition, and it was passed down by word of mouth, pictographs, petroglyphs, winter counts, hieroglyphics, Huapu knots, and other recorded keeping systems. But today, the information about us are found in our national archives, in libraries, and in government. I say government file cabinets because there's stories about really important information about our history, about our kinship, and things that really are important to us, but yet they're in paper and they're in government cabinets. So these concerns for accessibility of these records and how we work with those records is of great interest to tribes in America. And so we need to think about how we can begin to work with these archives, with the government, and how we need to go forward to develop these strategic initiatives that's going to support not only access to these records, the digitization of these records, but understanding again how that really is going to support our tribes going forward in terms of planning and in terms of how we build our nations. Next. So, we've come up with a list of recommendations. I think, again, this is uniquely to the United States, but I think this idea of accurate, relevant, timely data should be part of a federal trust responsibility. So if you know this, in America, our tribes, our nation signed treaties with the federal government. And out of that treaties came a trust responsibility. So there's a unique relationship between our tribes and the federal government. And so we want to continue to advocate for that. I think it's important that we build the data infrastructure and capacity in Indian country. That's what we call ourselves. So that these opportunities of mutual beneficial partnerships between our tribes, our nations, academic, corporate, nonprofit, and government sectors is really important. We want to be a part of this, but also we have unique needs that we need to do, and that's part of the infrastructure. That's things that are really being recognized today with the COVID-19, and how a lot of our families and our students, our young people are required to stay home and to isolate. So they need access to high-speed internet. Well, we don't have that as much as we should. So we're recognizing that. And so I think it's important that we understand that and we figure out how to address that. We know that data collection and those practices are costly. So a lot of our tribes in America do not have the revenue, the funding really to build this infrastructure. So we have to recognize that, and we have to figure out how we do that. I think trust is really important in dealing with our federal agencies and working with tribes. That's an important point. And we say progress moves at the speed of trust. For my own tribe, the Rosebud Sioux tribe, we know that we need to expand our data collection efforts. We know that we need to do that because we have many different people who live on our tribal homelands and our reservations, and so we have to figure out how the policies need to be in place, the law need to be in place, and how we practice those laws to work with data collection and data access. again, the point is we need more tribal data tribal members who have data skills to address these issues. So we need more of a workforce now to do this work. And that's a long-term goal. But right now, we're doing the best we can. And so we think about organizations like tribal colleges and universities, which I come from, to be part of that solution. And so that's really important that we think about that. We also think that because, of our unique status in America, we think that we need to continue to build these intertribal collaborations so that we can foster best practices, and we can foster innovation of how, because of our situation, because of our challenges, that we can progress and move forward in terms of not only the fundamental aspects of data, but also what makes sense for us individually. Next. So, as we really think about data from a tribal perspective, I think it's important that the human dimension is always involved in these things. I know that when I talk to my knowledge holders, our elders, they talk to me in stories. They tell me about how we came to be and our history and the importance of that and our relationship to the land and all those things that really define us. And so the narrative, the meta narrative is our way. It's always been our way. So those of us who are promoters of data, we are still information gatherers. We're still information keepers. And now that technology has evolved the way it has, then we need to figure out how that supports our storytelling process. Just as our ancestors, we still look for essential information to tell the stories. So we understand that we have tremendous challenges yet today in 2020 as tribes. And so we're looking at bringing both ways of knowing into the story to address our real immediate challenges like COVID. All those real life, real challenges have showed us again, demonstrated to us that the importance of looking at data as an asset to nation building. So when we think about the future, when we think about our people, we know that this is part of the conversation that we have to have. We have to be engaged in things like this. We have to continue to be a part of the platform of these discussions about the role of data, Earth observations, how that can contribute to our tribe and to our culture. Next. So we're doing things as the Geoindigenous Alliance, and I want to highlight two things that are are ongoing. First one is the Geoindigenous Hackathon, COVID Hackathon. Again, I like this project because it brings together technology, Western science, indigenous knowledge, young people, and mentors. And it's a really good model, I think, how we go forward in terms of bringing state-of-the-art data to our indigenous communities, but most importantly, addressing critical issues to the community. The second activity is that we continue to build our community. We want more indigenous thought leaders to be part of the discussion, part of the alliance. And so how we do that is we bring yourselves together. Now that it's more effective, or there's more opportunity to come together, like using these internet platforms, we can do that now. We can see each other from all over the world. And so we're promoting this idea of the Indigenous Alliance Summit, December 7th through 9th, 2020. You are all welcome to participate in the summit. We hope that you do. Again, this is bringing together indigenous thought leaders around Earth observation and traditional knowledge to really address and talk about the most critical issues facing our communities, like COVID-19, like climate change, and those real difficult issues that we challenge, that's before us. So with that, next slide. So I just want to thank you again. Wopi Latanka Ichichiapalo. Thank you very much for this time, and look forward to continued discussion. Thank you. Back to you, Warner.
You're muted, Mike. Warner.
Thank you very much, James, for this very interesting presentation. I don't see any urgent questions in the Slido, so I will move on to the next speaker, who is Connor Delaney. Connor is the technical director at the Secretariat of the European Marine Observation Data Network, EmoteNet. And EmoteNet is a long-term marine data sharing initiative of the European Commission Directorate General for Marine Affairs and Fisheries. Connor has over 20 years of experience working across disciplines of IT, environmental science, and big data, participating in research projects and delivering software in both the public and private sectors. A major theme of Connor's career has been using technology in innovative way for scientific research by firstly understanding the needs of the users. He designed and developed a GIS framework supporting hydraulic models for water management in the UK and shellfish aquaculture management in Ireland. Connor, the floor is yours.
Thank you very much. You can hear me okay? Yes, I assume so. Can we have the next slide there, please? And I'll start off. Hi, I'm Connor Delaney, and I'm going to take a slightly different tack here, I imagine, from previous speakers. You know, when we look at the Earth from space, through Earth observation, we see a very spatially large extent at a lower resolution. And it tends to give an impression of a very unified environment below us. So what happens when you're looking at on the ground or below the water at different temporal and spatial resolutions, and in fact from different thematic areas? So as previously said, I come from EmoteNet, the European Marine Ocean Data Network, which is funded by the European Commission. And if you think about it, if you as an EU citizen or any citizen of the world, when you're standing on the beach looking at the sea, you regard it as a unified space. You're by the sea and you're enjoying yourself. But in reality, from the scientific viewpoint, you're standing on the beach you're standing on is geology. The windmills in the sea, they're human activities. The seaweed and the fish in the water are biology. The temperature of the sea is physics, and the content of the water is chemistry. And these all get measured by their communities, and there is a tendency for these data to be stored separately or stored in stored together, but not stored in a way that they can be used with each other. So next slide, please. So in EmoteNet, we are literally a network based on this idea of the different ways that the marine observations are made. And it exists of a number of thematic lots for bathymetry. Here we have geology, seabed habitats, chemistry, human activities, etc., who operate their own, at the moment, their own portals where they make data and data products available. Next slide, please. So the challenge for the EmoteNet community is to make this data rapidly accessible to the user. And we have a central data portal from which you can navigate to these other portals to access this data. This gives the impression, of course, that we are at a unified, quite linear organization. But can we next slide, please? But in reality, we are actually sitting on top of the work of European and international science community. We don't collect the data or make the observations in general. Sometimes, in some cases we do, and most of the time we don't. We are getting the data observations from national organizations, member states, NGOs, pan-European research consortiums, and we're collating, quality checking and publishing the data through each of the thematic lots, as you see listed here, which are accessible through the central portal. Next slide, please. And I mean, literally, these thematic lots are quite distinct from each other. Each of them has their own IT infrastructure for storing, collating, and sharing the data. It tends to be based on what each of these communities are used to. So EmoteNet physics is made up of of subject matter experts from oceanography and in situ observation of the oceans, and they would tend to use technologies that they are familiar with. With Thematic would use different technologies, and they share out their data in a way that we can try and use together. So next slide, please. I'll just come on to that now. So in order to make all this data and data products available to the greater community, we have to follow certain unifying principles. So we use the INSPIRE directive, which is a EU Commission directive on geospatial data infrastructures. We use the FAIR principles for sharing data to guide us on how we make these data and data products available. So we have data products, metadata, and data services. And one of the most powerful tools we use is OGC, the Open Geospatial Consortium, definitions for web services, for web mapping services, web feature services, etc. So the central portal works hard with the thematic portals to make sure that we have interoperability going across the portals and out to the greater community, along with enough information that people can understand the context of the data, and even if they need to go back to the original publishers of the data with queries and further questions. So next slide, please. So what other guiding principles is that we try to collect data once and to use many times. And we're trying also to leverage the collective efforts of the EmoteNet network. I don't know if you're familiar with it, but ships carry little transponders that identify where they are in the world. So it's sort of like they tweet all the time their position, for example. They're not actually tweeting, but that's what you can think of it. And this data gets picked up by satellite or by coastal observatories. For an individual user, this data is way out of their technological or cost possibilities, because the data can be expensive and it is actually big data, so it's hard to process. So our community has gone out to find this data and make it available through the EmoteNet portal. So in this case, it's human activities, because shipping at sea is human activities, and they make this data available to anybody who comes along to the portal. This data is open and free to access. So next slide, please. So getting the idea now that we have these separate portals that are focused on themes, and they are publishing data that's free to access and to use in most cases. This is something I'll come to in a moment. But they also work together. They work together to produce data products. Now, the openness of the data that's in the system is reflective on what the national member states' attitude to open data is. So in most cases, the data is open. In some cases, the data can be restrictive. So we have to cater for both situations. And we try our best to make the data at least discoverable and at best open. But some cases, we're waiting for member states to change their data sharing policy. So next slide, please. So when the thematic groups work together to make this data available through OGC services, also through data products, which are downloadable, allows us to produce products such as the European Seabed Habitats Map here, where we're taking data from geology, physics, seabed habitats, bathymetry, and we produce a map for Europe that can be used by any researchers in Europe or anybody in Europe who wants to access the data, that is trusted and well defined and has good, strong metadata behind it. So next slide, please. So the extent here, just to give you an idea now, we have a huge amount of data and available, diverse data. It's not singular data sets. So like in bathymetry, they survey tracks, water depths, depth profiles, undersea features, shipwrecks. And the challenge, of course, is to make this data interoperable. And it's something we constantly working on. And also the challenge is to make sure that we're not missing out on data. So each of these thematic groups are subject matter experts in their fields. So they know the European landscape. They keep in touch with the different projects producing data, and they try to bring the data into the EmoteNet network. So you got to bear in mind as well that for many member states, they only publish data up to a national level. To produce European scale data sets, we have to get those data sets and then join them together to make a European scale data sets. And sometimes these data sets are not all published to the same standards. But that's changing over time. So next slide, please. So the great result of all this effort is that we produce these data products. And these data products are fully free and open. They're funded by the European Commission, and you can come along and take them and use them as you see fit. And they're very, very useful. And they're, as you can see, very, very extensive. So the next slide, please. We make these products available on a central portal through a central map viewer. And in this particular image here, you can see that we're making, you can see the aquaculture sites on the coast of France there and Belgium. You can see the windmill sites in the English Channel, the ocean windmills. And we have many more layers which you can switch on and off to get an understanding of the situational in coastal areas. So this is very important going forward for marine spatial planning, and we're trying hard to make our data suitable for marine spatial planning. It's something we're constantly looking at. But also on a technical perspective here, we're dealing with two communities now, technology-wise. When EmoteNet started 10 years ago, open data was very much in its infancy, and there was a tendency for spatial data infrastructure where you could query metadata, and that would lead you on to information that allowed you to contact data producers, and data was still very much behind restrictions. So we have this system now of geospatial infrastructure that comes out of that legacy, and it's evolving all the time, and it's also serving the geospatial community. And if you go to the next slide there, please. Because we make all these layers and data sets that are available through our map viewer, also available through a data catalog, a geospatial data catalog. So these would be high-level data sets, and I invite you to come along and search the catalog and use these data sets. So in recent times, with the advent of cloud computing and data opening up, there has been an increasing move to data science. And for next slide, please. And what I mean by data science, I mean people who are not so interested in getting geospatial data products. They're more interested in getting aggregated data products, which they're able to either run on their desktop or run in the cloud, and they use technologies like R or Python to do that. So we're trying to cater for both of these communities. And recently we moved descriptions of all our web services to a central GitHub repository, so anybody can go there and access them and understand how they can use through R, in this case, tools to consume the data from our network. We also have gone into great effort to produce use cases, which we publish on the central portal. And this is extremely important, especially when you have people who are trying to solve problems and know that they need marine data to do that, but don't know how to use it or what type of marine data it is. So, there is this tendency or this phrase that goes around that we need to find value in our data, or we need to make our data valuable. But my argument here would be that this is scientific data. This is already extremely highly valuable. What you really need to do is find out how it can be used. There's an awful lot of effort that has gone into getting this data, making these observations, an awful lot of effort has gone into making sure that these are quality controlled and well described. So the value is there. It's about unlocking that value for many people. And this is why use cases are important. So next slide, please. Well, a great advantage of using this open service, web service approach is that we can engage in other activities. We're involved in ocean literacy, from the DG Mare European Commission point of view is very much focused on the European Atlas of the Seas. The European Atlas of the Seas, which is a wonderful resource, and I recommend you go there, can directly link to the data sets, web services within EmoteNet for EmoteNet products, and it does so. And we are one of the main suppliers of data products into the European Atlas of the Seas. Next slide, please. So we've just kind of finished a decade of progress, and we're moving to the next decade. And one of the major changes for us going forward is that we will be one by one shutting down those thematic portals. The thematic lots will continue to work because these are subject matter experts who know the data they're dealing with and also know their communities. But we're bringing all that data querying technology into one central portal. So no longer will users have to go out to the thematic area portals to get the data, and they will be able to query the data sets on a geographic basis. So one of our geospatial units is a sea basin area, so you'll be able to query by sea basin area what data is in that. So we're not just in looking. One of the keys to our success is that we are realizing that we cannot be insular. We have to be looking to the broader marine observation community, because the marine observation community is remarkable. It's very, very strong at data sharing, at metadata standards, at sharing technologies and sharing data and working together for a better future. So we keep an eye on what's happening around the world. The next slide, please, which gives us a global outreach. Now here, in this case, is an example of the Data Buoy network, or the Ocean Buoy network, which has presented through EmoteNet Physics. Now, once again, we don't put these buoys in the water, but we're using technology made available through the USA NOAA and through French from our Argo buoy networks to bring together these data sets in one place so that you can see the full extent of the data that's out there. And in this particular case, our colleagues in EmoteNet Physics have been keeping very much aware of new technologies, and they're using a technology that is growing in more and more usage in the marine observation community called ERDAP, which allows them to link ERDAP servers around the world. And I have a link there of efforts that were done by our colleagues in the Irish Marine Institute, who have actually built a website that allows you to query all the ERDAP websites around, all the ERDAP web servers or data servers around the world from one spot. I think it's quite remarkable that we're rapidly approaching a place where data archives will be queryable from one spot and return data in a way that can be used interoperably. So next slide, please.
1 minute left.
So this global outlook from our colleagues in EmoteNet Physics meant that they were able to go and help out in building this Southern Ocean observing system. So they used their skills and technologies they have accumulated and have brought into place this in situ observations in the marine area around the Antarctic. Final slide, please. I just want to give you an overview of some of the international collaborations. We're currently very much involved with working with the national marine data centers in China to improve interoperability between the Chinese and the European marine in situ observation data archives. Please come see EmoteNet and use it if you're everywhere involved in marine observations, even if they're from space, because we have lots of in situ data. Thank you very much.
Thank you very much, Connor. And we are quickly moving to the next presentation, which will be given by Fabio Andres Banal. and he will be talking about advantages of data sharing and Earth observation products in the hydrological forecast in Colombia, and he will take a data economy perspective. Fabio is an official of the hydrology division in the Institute of Hydrology, Meteorology and Environmental Studies of Colombia, where he has worked since 2009, and he's currently the coordinator of the Hydrological Modeling and Forecasting Group. He has recently coordinated projects in flood hazards, sudden floods, and hydrological prediction. He holds a civil engineer and master in engineering with an emphasis in hydraulic resources from the National University of Colombia, and also a master in disaster management from the Graduate Institute for Policy Studies in Japan. Fabio, the floor is yours.
Thank you, Werner. Thank you, everyone, for the opportunity to share our experience in Colombia. Next slide, please. Well, I will today want to share with you, I belong to the hydrology division and the growth of hydrology and forecasting modeling. Next, please. I will share with you today some general aspects from Ideon, the products and services it offers, and how the GeoGlob's ACMWF hydrological forecast tool is being used in Colombia, as well as some difficulties, shortcomings, gaps, and opportunities about these tools. Next, please. Well, Ideon was created by Law 99 from 1993. It comes from an older entity that managed the environmental and hydrometeorological network in Colombia. Ideon's purpose is to generate knowledge, reliable and timely information for natural resource and environmental dynamics, to facilitate decision and making process and adjustments of environmental policies by public and private sectors. Next, please. Ideon is the maximum hydrometeorological authority in Colombia, monitors stream flow and water variables in rivers, including water quality. It's a public agency within the Ministry of Environmental and Sustainable Development. It provides knowledge, technical scientific support to national agencies and economic sector, including regional environmental authorities. It coordinates and manages the environmental information systems of Colombia. Its main function is to monitor renewable natural resources, forests, water, soil, and air in terms of status, demand, quality, and variable in space and time. Provide also hydrology and meteorological and environmental information data free to every user. Produce inventory and information of management of environmental policies and territorial development management. It's important to highlight that Ideon issued the official hydrometeorological early warning and forecast to the National Risk Management System. Next, please. Between the products are provided by Ideon includes environmental forecasts, early warning, provide protocols, technicals, and thematic guidance from national to local levels, provides hydrometeorological and environmental data from information associated with the network. Ideon manages the national hydrometeorological networks. There are some regional networks, but we are going to integrate information for that. Also provides accreditation for environmental laboratories for specific variables. Provides information in the national environmental information systems. Provides climate service to protected sectors like energy, health, and agriculture. Monitoring climate variability and produce climate change communications according with IPCC guidelines. Also provide service and support for the aeronautical sector. All the information is available in our portal, in the platform. Documents are available and thematic shapes and PDF are available in our website. Next, please. Well, between the products we share include forecast and warning for hydrometeorological threats that are made by publishing bulletins with early warnings or technical documents, and also we have public web service for information in real time that is available for the user, and also the historical data. The group of hydrological modeling forecast, called also National Modeling Center, must provide hydrological tools, criteria, and models for the early warning office. It's made by FIUS Colombia. This is flood early warning system that allows to share and manage multiple source information in real time that use data of level values and discharge derived from measured water levels and rating curves. You can see there are some colors in points and basins. There are the main basins in Colombia, and there are some points in colors that shows the warnings related with rivers that we have available in website and also in bulletins that are produced daily and each 4 hours also. From these main basins in the white line, 40% of these basins have almost one station of hydrological monitoring, but not all are in real time. So we have around, in total, 700 stations, 260 of that report to the early warning office in real time or conventional by phone to provide early warning system tools to provide bulletins. So in areas with poor information, it is necessary to have tools that provide useful information to generate early warnings. Next, please. That's why Ideon participates in the GeoGlows ACMWF Streamflow Forecasting Service project. We made that using the global tool provided, and also Ideon shares some historical in situ data to compare the results of this service. These products are available nationwide in Colombia. There is an image that showed out the blue reach have each one in the original tool some forecasting elements that are showing these figures. The forecast is 10 days away. This is midterm forecast. The green band is the historical data set range in variation of the period of time. The band in the upper part of these graphs are the term periods estimated from the historical data. You can see also the historical streamflow and flow duration curves for each of these reach in blue lines there. The red points are the stations in we have real-time information, and the original model represents the intra-annual behavior in some places. We have in some places 2 high levels period, and in some places we have 1 high level period per year. So the GeoGlows streamflow forecasting can reproduce these months in the year that they are produced. Next, please. Well, GeoGlows through Thetis portal EduViewer developed by Brigham Young University make a shift from Colombia, from the global tool, and configure some tools additional for us. We share the data from views, level and discharge, and we can now use to compare our some efforts. In the left part, you can see the GeoGlows tool to provide 10 days of forecast. The blue line is the present time, and you can check if how short, mid, and range forecast violence throughout the country, and close attention in place on areas where potential flood has been forecasted. Where local model exists, both forecasts, Ideon and GeoGlows ACMWF, are compared to emit warnings in areas with poor density monitoring stations and non-local models. This tool can be used to emit warnings or decide if we can launch some early warning to maintain for some few days because there is another possibly event occurring in the next days, or to reduce the warning level within the time. Next, please. Well, combined with the fuse forecast that is just 3 days ahead, we can change from global tools to local tools using in situ data and some correction of the global forecast. This is made also for the Brigham Young University, a bias correction tool that shows us that the values of the simulated discharge that is in red lines in the picture is corrected to the green one and get more close to the observed data. That tools show us that this correction from bias allows to get better results for the visual analysis of historical data and also for the forecast. The university developed some metrics of the original full-time series and the corrected full-time series. You can see that the improvements are significantly and allow us to get more accuracy forecast from this tool. The station show is a Nazareth station on Amazon River. This is a transboundary area, so also we can use in areas with poor information and in areas with transboundary rivers to get some forecast more accuracy. Next, please. Well, it's important to highlight to encourage our countries to share in situ data for the calibration of global models. Bias improvements are needed, and an interaction with rivers and flood areas might affect sometimes the difference with the observed and real data. For now, it's important to highlight to share in situ monitoring networks to improve global forecast model to local needs. Also, there is a gap for now, that is to extend the bias correction at reach without stations by regional analysis and bias correction techniques. This is important to obtain global wide national forecast in accuracy values. We have some opportunities, that is also to use flood map pilot applications will be evaluated with the stream flow forecast and flood maps. It can be combined with existing hazard maps we have in Colombia as an approach to impact-based forecast. Also, another opportunity is to use satellite Earth observations to forecast flood extent. This will be useful to try to get also in advance the extension possible of flood based on the discharge values of the forecast. Next, please. Well, some takeaways. Sharing local data with Earth systems improve decision making. Global forecasts fill gaps where local data and models do not exist. As I showed you before, the Orinoquia and Amazon region of Colombia have few stations, and also they have big rivers, and this tool can provide good decision making tools to improve the results and the warnings provided. We can redirect limited resource to better decision making. That is very useful for us in regions. We will have enough resource to make the tailored models for all the basins that we have, and we can optimize our resource to analyze all the country. Opens new possibility for larger scale flood mapping, use of machine learning and satellite data to generate new products associated with the forecast. Next, this is the last, I think. So I want to extend my gratitude to all the community on GeoGlows that allow us to make this application. NASA from GeoGlows and Angelica Gutierrez and Professor Jim Nelson, who supports us to support this utility. Thank you very much.
Thank you very much, Fabio. I think this was an excellent example how in situ data can support services like weather or flood forecasts. Our next speaker is Henry Stein Andersen. He is working as a contract manager at the European Environmental Agency, where he is responsible for the cost-cutting coordination of the Copernicus in situ component, as a task delegated to the European Environment Agency by the European Commission. In that capacity, he is cooperating with all the Copernicus entrusted entities and with data providers in the Copernicus participating states. Henrik Stein Andersen has a PhD degree in remote sensing from the University of Copenhagen, and before joining EEA, he was working for the Danish Meteorological Institute. The title of Henrik Stein Andersen's presentation is Copernicus, Europe's Eye on Earth, Data Sharing Success and Challenges. So Henrik Stein, the floor is yours.
Thank you, Werner, and good morning and good afternoon to you all. You can move to the next slide, please. Today, I will briefly introduce you to Copernicus and its data sharing successes and challenges. Copernicus is the European Union's Earth observation program. It's an operational program looking at our planet and its environment for the ultimate benefit of all European citizens. Through its open data sharing policy, Copernicus is having a very visible impact on the uptake and use of Earth observation data and information, both by the public and private sector, by downstream application and service developers, by academia, and by the citizen in general. So Copernicus is offering information services based on satellite Earth observation and in situ or non-space data. The program is coordinated and managed by the European Commission. It is implemented in partnership with member states, the European Space Agency ESA, the European Organization for Exploitation of Meteorological Satellites EUMETSAT, the European Centre for Medium Weather Range Forecasts ECMWF, EU agencies, and Mercator Ocean. So next slide, please. So today's theme is data sharing. On one hand, Copernicus is sharing a huge amount of data and information with its users. On the other hand, in order to produce and validate the data and information products, Copernicus needs access to additional satellite and in situ or non-space data. So Copernicus offers a lot of data to its users, but it also relies on other data providers' willingness to share their data. So next slide, please. Copernicus, very briefly, consists of three main components. The space component, including both space and ground segment and dissemination systems, acquires and delivers data from seven operational satellites, the Sentinels, and more are currently being built and will be launched during the coming years. The service component is composed of 6 services focusing on different thematic domains. So there is the atmosphere service, the marine service, the land service, climate change service, the emergency management service, and the security service. All these services, they produce a lot of different products like air quality forecasts, ocean forecast, land use data, climate reanalysis, emergency management maps and analysis, and security maps, of course. So there's a lot of products being produced by these services. The third component, the in situ component, in fact illustrates that Copernicus requires access to in situ data for production and validation of its data and information products. This is important because, as you know, if you are doing ocean modeling, for example, you will need to look below the surface. You will need information concerning the state of the ocean, and you cannot get that directly from satellite data. You need in situ information to do that. The same is true if you want to validate your air quality forecast. If you want to do climate reanalysis back in time, you need historical observations, and so on and so forth. I mean, it's clear that it's produced by Copernicus need access to in situ data to produce them and also to validate them. And I should also maybe underline that when we talk about Copernicus, continuity and long-term service provision is a key principle working across all these components. So next slide, please. So the Copernicus program is extremely successful, and its free and open data policy is fundamental to its widespread use and impact. Satellite data and in situ or non-space data are being used to provide information to help service providers, public authorities, and international organizations. And it's about improving our knowledge about the environment, about climate change, and also to support crisis management. The information services provided and shared are freely and openly available to users. This is really a key feature of Copernicus, the open and free data policy. Vast amount of global data from satellites are being shared by Copernicus. We are talking petabytes of data, millions of products, and we have now more than 350,000 registered users. And those users can actually also then redistribute the products and the data to other users. So we are just seeing the tip of the iceberg, in fact. Hundreds of quality controlled and operational products are made openly and freely available by the Copernicus services. Copernicus is also sharing in situ data received from external providers. This happens primarily through the services data portals and according to the license conditions, of course. It is important to underline that while Copernicus is creating and managing the space and service components, Copernicus relies predominantly on existing in situ data capacities, and it is therefore not implementing an in situ observing system of its own. Member states, organizations, observing networks, research infrastructures, and many other in situ data providers' contributions are essential to Copernicus and its success. The next one. So Copernicus is strongly involved in promoting and strengthening data sharing, and it is leading the way as an example, I should say, of efficient and open data sharing. However, there are still key challenges and barriers that need to be overcome to ensure Copernicus access to essential in situ data needed to produce and validate Copernicus data and information products. These challenges are predominantly related to use restrictions, license condition, accessibility, sustainability, and of course also coverage. In certain areas of the world, it's not that easy to get the data or observations you need. To circumvent these challenges, Copernicus, and that is actually the space agencies, ESA and EmoteNet, the services and the entrusted entities, and the European Environment Agency, as responsible for the cross-cutting coordination of the in situ component, is taking numerous initiatives. So I would just like here today to name a few examples. So with the purpose of getting access to more data, relevant, essential in situ data, I have named a few of these initiatives. So let's look at international cooperation, for example. The Commission is setting up cooperation arrangements with non-EU countries such as the United States, India, Brazil, Colombia, Chile, Serbia, Australia, and Ukraine, and more will follow. Data sharing is a key element in these cooperation arrangements. So, I mean, the basic idea is that Copernicus will make a lot of data available to these countries, and of course we hope to get then some data in return. So this is the basic principle behind these, what we call cooperation arrangements. Then there is this issue about recognition and dialogue. It is extremely important to recognize contributions made by data providers and owners to Copernicus. We are working with key networks and research infrastructures to highlight their essential contributions and to underline the importance of their continued and sustained support. Evidence that could be conveyed then to national and other funding agencies to justify continued funding of these observing networks, for example. Then we are looking at what we call support activities. And it is evident that, of course, many of these observing networks and research infrastructures are not originally designed support and meet Copernicus requirements. We are consequently seeking ways to support and fund activities, allowing them to meet these specific Copernicus requirements, such as timeliness and accessibility. And Copernicus is also funding data rescue activities, exactly with the purpose of having historical data, the historical data you need to do climate analysis. Partnership agreements. Copernicus has signed partnership agreements in particular with key European networks such as EmoteNet, Eurogoose, Eurogeographics, Eurogeosurveys. These partnership agreements form a solid foundation for further cooperation, knowledge exchange, and of course also data sharing. Then there's another important thing that we need to highlight here. So awareness raising. It's not obvious, of course, that it's clear to all in situ data providers and in situ data owners why they should contribute to a program like Copernicus, why they should make their data available in an open way. So awareness raising and communication activities are necessary to inform decision makers and data providers about the importance and use of in situ data. Services, the entrusted entities, and the EA are creating information products with a view to demonstrate why data sharing is important and how the quality of the Copernicus data information products is impacted by the availability of in situ or non-space data. Then we also have to look at the at EU policies and initiatives. So how are we leveraging actually these policies and initiatives? The EU is implementing legislation and policies that support and promote data sharing and is funding initiatives meant to facilitate and improve data sharing. EmoteNet, for example, you just heard about that one, is a very good example. And there is also a very good cooperation between EmoteNet and Copernicus, in particular, of course, the Copernicus Marine Service. The research and development program Horizon 2020, for example, is also funding projects leading to better coordination of in situ data observations and also data sharing. And the Inspire Directive was also mentioned before, but the Inspire Directive and also the Open Data Directive are two examples of relevant EU policies. Copernicus is, of course, leveraging these initiatives and are really also now benefiting from geospatial data made available by member states via the Inspire data portals. And of course, we also need to look at the high-value data sets currently being discussed with member states, and they will, of course, most likely be of benefit for Copernicus. They are going to be made freely available in the future, hopefully. And what I would like to mention here at the end, internal coordination, internal inside Copernicus. It's clear that we are now looking at the first phase of the operational program. It's about to end now, end of 2020, and then in 2021 there will be a new phase of Copernicus. 7 years of funding will be made available, and during all these years, of course, a huge amount of in situ data are being collected and also managed by the Copernicus Space and Service component. It is therefore important that we ensure internally that data are being collected and managed once, thereafter made available to all relevant services to avoid duplication of work. This, of course, requires efficient internal coordination and activity that, of course, will be in focus during the coming year. So it's not only about sharing data with all our users, it's also about relying on the willingness of data providers to make their data available to support what we do. Of course, it's also about internally within Copernicus to ensure that we are sharing all the data we can share with each other. I think that is my last slide, and thank you very much.
Thanks a lot, Henrik, Stein. We are now coming to the to the discussion, so please switch on your cameras again so that the people out there can see you. I received the questions like a little bit with a little bit of delay, so I will try to group them. And there are, I think, two questions for James. And one is, what would you suggest is the next step for GEO, national, federal, central government members, and indigenous nations to work together in GEO?
Well, thank you for the question. I really think that it's going to take leadership both from the GEO community side as well as the indigenous nation side to begin to articulate what an effective partnership would look like. I think with that, I know that that GEO does have formal partnership mechanisms to bring together, whether it's private sector, academic, or national states. I think it's important that GEO recognizes the sovereignty of our tribal nations, and to begin to really think deeply about what that might look like. I think the other part of it too is, given that a framework can be developed where more and more of our indigenous scholars, leaders can participate in GEO flagship type programs where we raise the visibility of indigenous issues around Earth observation, around data sovereignty, around data education, and so forth. So I think that's the other part, is that we have to create opportunities for us to participate across the board in terms of GEO programs and GEO flagships. And then finally, I would say is that really it's an idea about bringing together resources so that indigenous nations and peoples can fully participate in these programs. And so I think, it takes leadership. I think it's participation. It's again developing new relations in a new era so that we can work together.
There is a second question that is about your strategy to broaden the participation in the Geoindigenous Alliance. So, for example, do you have a strategy to reach out to Arctic Inuit or to other indigenous people?
Right. Well, I think say again, the Geoindigenous Summit is coming up here next month. I think it'd be helpful to us in planning for that those who have indigenous partnerships in place now, those who know those leaders in indigenous EO work can be aware of the summit, and that we can invite them into this discussion, have a really good dialogue, good forum about their interests and how collectively we can work together to advance our own goals as well. So the summit will be a key activity next month to really get a sense about the interest level, really about what we can do together as an indigenous community and coming together with the GEO leadership. Especially, we have a new secretariat coming in. Gilberto is gone. We thank you for your service, but also we have new leadership. So I think it's a new opportunity, again, to build the foundation for a strong, strength-based partnership between the indigenous people and GEO.
James, I have a personal question that I may take the liberty to ask you. I am a European scientist, and whenever I'm working in projects with indigenous people, there is this this buzzword of capacity building coming up, and the more experience I'm gaining is the more I think this has sometimes an arrogant, one-sided attitude from the let's say Western people, that we might think we should build capacities in computing sciences and things like that. But I'm working in climate science and climate change mitigation, And I think that capacity building should be also the other way around. And indigenous people very often have livelihoods that are connected with much lower emissions, for example, and much closer to nature. And I was somehow fascinated from your idea of storytelling and sharing your experiences. So my question is, how I know the importance of your data for your cultural identity, but I think data sharing beyond your communities would also be very interesting in this kind of capacity building, that we Western people might learn much more about climate mitigation and close to nature lifestyles.
Well, thank you for the question, Werner. I think you're aware of, I think, the contributions that indigenous people have made to the world, and through our land, through our knowledge, and through our spirituality. And I think it's important when you talk about capacity building that it's done together. I think that's why I always encourage that with the GEO leadership, that this isn't another outreach activity, but this is going to be central to the future of GEO and how it works with indigenous people. I think it's also important to recognize that what they say 80% of all biodiversity is within on or adjacent to indigenous lands. So when about that, if we really want to address issues globally, we got to have indigenous people at the table in terms of discussions. And I think when you come together like that, when it's really important, like climate change, or even talk about emissions and capacity building, I think that's what has to happen. We have to create a platform of equality, diversity, and justice. And so we have to work those things together. And I think under your leadership, Warner, and others, we allow that to happen. We come together. I think we can make progress. But knowing that it's difficult, it's not easy. But again, there are those of us that want to see this happen. Those of us that are supportive of these engagements built upon, again, equality, inclusivity, and justice. And I think we can make progress. So I appreciate your question. And yeah, all those other things matter as well. The computer science, the training, the software, all that matters. But also, I think that if we're really gonna address like the Paris Accords and the role indigenous people play in addressing those things, and for sure, we want to be part of those discussions.
Thanks a lot. So I have a few questions for Connor, and one is, or perhaps I will ask two together. One is citizen monitoring contributing to EmoteNet products? And the second one is, how does EmoteNet collaborate with GEO?
Two good questions. Citizen monitoring is part of some of the thematic groups, but I'm not actually up to speed on any particular projects that we're working on. The extent of EmoteNet is quite wide, so it's hard to keep up to date with everything going on. But it would come through maybe through the biology group or one of the other groups that are using citizen science to augment their products. So from the GEO perspective, we just make our data available, and we keep an eye on what GEO is doing, and we follow GEO's recommendations, and try our best to interact with the GEO community. In particular, we're very keen on using open source and open geospatial consortium tools to promote our data products. So it's not like we have active engagement. We're trying to have follow a normalization of what is open geospatial, for example. It shouldn't be seen as exceptional anymore. It should be just normal. Metadata is just normal. These are just normal things that we do now. And we just very much, our approach is that these are the normal basic things we do. And we are very much believing that this is how our communities now expect things to be. So that's So we answer those.
There's an additional question on the WMO data conference that will start in 2 weeks and will be reviewing data sharing approaches. Do you have any thoughts on this?
I'm giving a poster at it with my colleagues, and we will be looking at briefly going over what EmoteNet does in the poster, but we're probably going to be focusing on the exciting technologies that the physics community, ocean physics community use, like the AirDAP technologies, because that's quite I find it quite a modern way of thinking about how you share data. In this idea that the server is there, the web services are RESTful, they're easy to understand. You don't have to spend a lot of time understanding how to access the data. The information on how to access the portal is available. So you're really, and it's also, you can either approach as a human or you can approach as a machine to access the data. But it's this idea that these things should now be accepted as just being now normal, not exceptional anymore. And that we need to be dealing in that community and dealing in that space.
Thanks a lot. The next question is about standard, and it's going to Fabio. You have shown the value of in situ data for model validation. Is there any need for GEO to set or to support standards for in situ data to facilitate the use?
There will be a useful help, because we share with, in some cases, with the standard formats provided by the Fuse platform, but also provide more standards for sharing other information, or also for other entities networks will be useful to get more information for other stations and share with more easily way and in standard and stable platforms.
And there's finally a question to Henrik. How does Copernicus deal with historical data, for example, from various sources, different methodologies, and how are you going to lower the problems with this data in the future? I can't hear you. So it looks like we have no, we can't still hear. No, that's unfortunate. We are not hearing you. Perhaps I will then go on with a question that perhaps is for all the panelists, and when Henrik has solved his problems, he can also answer this. And the question is, what is the most significant progress you would like to see made by GEO or through GEO over the next years in terms of open data? So perhaps we go along the same line as the presentation. So, James, what's your perspective?
Well, I think that it's important that we sort of have this coming together with Indigenous leaders in terms of the idea of open data policy, and really beginning to sort of articulate what that might look like in terms of a long-term strategy for GEO and the idea of open data. You know, there's always been concerns among Indigenous people about the idea of an open data, and so I think we just sort of continue to bring those thought leaders together from Indigenous side to really address the complicated issue of open data and how that can impact indigenous people in terms of their lands and their culture things. So I would hope that we can, like this, continue GEO to provide leadership to host and convene deeper dives into the idea of open data and what it means for indigenous people, broaden the participation in terms of, again, both sides from the industry, private sector, government, and such. So really take this on head on and put it out there and begin to work with it. So that would be my suggestion, is bring the voices together and begin to document that and then continue to work towards those things. So that'd be my thoughts. Thank you.
Thanks. Connor, what's your comment?
Hey, hi. Sorry, I'm going to be a bit technical here, so apologies for this. To me, it's very, very important to continue the promotion of open data, as we just heard, particularly in the area of environmental data. And on that topic, it's also very important that we go beyond just from being able to query metadata in just metadata catalogs, but being able to query metadata to get straight access to the data. It also, in my opinion, it would be very useful for GEO to be able to take on the role of open data education for environment, to try and join the dots between Earth observation and in situ data, and help the global community use these data sets in an interoperable way to come up with actionable information. Leadership is needed. I don't know where it's going to come from, but to me, this would seem to be a natural role for GEO.
Fabio.
Okay, I agree. It's also important to provide more efforts to sharing policies of data, because all of the products of GEO platforms and other global products, and including local products, can be shared, compare, and optimize when we can share information. We, for now, just share information in basic formats, common separated values and JSON and so on. But there are a lot of platforms that are allowed to make dynamic queries. Tools like are showing by my partner there, and also available to improve some specific questions that for some projects or other pilot the products of development of some information, because they have to filter manually a lot of all information maybe we have provided, but there is no tools that allow to facilitate these important query questions.
Henrik, are you back?
I don't know. Can you hear me now?
Now we can hear you.
Oh, good. Sorry for that. No, I mean, I can go one step back and try to answer this question about the historical data, because, I mean, obviously they are important to some of the services inside Copernicus. So if you want to go back in time, pre-satellite data, of course you need in situ observations, and we are very much aware of this. And I know that some of the services, the climate service, for example, they have data rescue activities. They, of course, coordinate these activities with what is going on already in, for example, in WMO and other places. So they are taking part in a global effort, in a way, to rescue these data. The same is true. We have also an activity ongoing in the context of the EA and the cross-cutting coordination, where we try to rescue and reprocess drifter data that will be made available, also openly available to everybody when we are ready with these data. Concerning data sharing and what we should do in GEO, I should underline, maybe if it's not known already, that of course Copernicus is seen as a major contribution from the EU to GEO, and that is my experience from working with European users, that we from time to time, when we ask users or data providers to share data at European level, they ask, okay, now why should I do this? Why can you point me to a European use case so it will make sense for me to do this? I think that's really important to underline the importance of sharing data, to underline why you should share your data with a program like Copernicus, for example. But I think also what we should do in the future is to point to the successes, because there are many. And we should not always try to focus on the challenges and the barriers, but we should also underline and provide very good examples of what's going on already, and all the data that are being shared already. We should not forget them. But of course, this is important. And as far as I can see from my experience, simply recognizing what is done already, simply explaining why data sharing is so important, is two main steps to be taken. But of course, I mean, at the end, you would also need to facilitate this through technical tools and data portals and sharing mechanisms and standards and all that. But I think to start with, it's really about creating this understanding that it's worthwhile sharing data.
Sorry, can I just second that? Henrik's made a very good point. The open data, as an environmental data scientist, open data is the most revolutionary thing that's happened in my sphere, my professional experience, and it can be challenging for people. They are frightened of it sometimes. They don't want to share their data. Sorry for interrupting, but that's a very good point he made.
Yes, I think we all agree on that. I might add something from my perspective, or from the research infrastructure perspective. So these research infrastructures are organizations where the European countries share or join their forces and build something that has an added value compared to single country programs. But ICOS is not the only environmental research infrastructures. There are infrastructures about biodiversity, about air quality, marine research infrastructures. And we are currently doing a lot of work in harmonizing our metadata so that data are becoming findable and also better documented. And I think that's something where GEO could even more support. I think we are good. We are well on the way in the research infrastructure, but there is a much bigger community of data sharers around, and helping them to get standards on the metadata, that from a user perspective, the metadata can be easily found, the data can be easily found and grouped from different sources. I think that's something that we really need in the future. We will have questions that relate climate change and greenhouse gases to biodiversity and so on and so on. And I think this is the next challenge for open and big data, that we really can combine different data sets, and their metadata is the key. And I think GEO could, from my perspective, play a really important role, not only for science, but also when it comes to services. Okay.
Ben, I don't know if I may add one thing.
Yep, you're welcome.
We also need to take into account, I think, that data provider communities are very different. Some are very used to sharing data. I mean, you cannot do a weather forecast without getting data from your neighboring countries. You cannot do a ocean forecast without getting access to data outside your own area. So, of course, they are used to sharing data. In some other communities, it's not that obvious. I mean, think about geospatial data, mapping agencies. They can work within their own borders. Why do they need to share the data? And that's things like that we should take into account when we are trying to explain the importance of sharing data.
But I have a personal, really positive experience, and that's FluxNet. So I worked with this CO2 fluxes of ecosystems throughout almost my whole career. And then some 15 years ago, people started to share data. And suddenly there was the opportunity, instead of writing a one-side paper, to get data from 100 sites and really compare scientific or test scientific hypotheses on hundreds of sites. And I think at the moment we are even close to 1,000 sites that are sharing data. And this was a complete game changer in the whole science. And I think many people profited also in their personal career by being co-authors in 10, 20 papers where they work together with other people on a big data set. So I think if you ask somebody from this community, it's everybody exactly knows how important it is and how favorable it can be to share the data. I got one additional question that is, I think, more about the governments. The Canberra Declaration. In the Canberra Declaration, the ministers said we should encourage governments to increase free access to Earth observation created using public resources. I think this could be a low-hanging fruit when governments say, oh, well, we support your observations or your scientific study when you are promising to share data from the beginning. But when it comes, for example, to governmental monitoring programs in the environment, then it might be different. So what do you think are the chief impediments that keeps us away from this happening? Any comments on that?
It's hard to relate to that because in Europe we have a Copernicus Earth observation program, which is pretty amazing, and all that data is open. So personally, I don't really know how to relate to that type of challenge.
Okay.
I know we have, for example, NASA and NOAA make all of our data available too.
Mm-hmm.
So but in the public space, there's amazing data sets available.
Okay, the public.
But
go on.
Sorry, yeah. So I don't know, Werner, if it's okay. I mean, this is also very different from one community to another. I mean, I can see in Europe at least that there's a trend towards more open data, also from public institutions. They are changing their data policy. But I can also see that for some communities, it is simply the case that they are asked to sell their data. They are asked to generate revenue from their data. And of course, it makes it very then difficult to share this data openly and freely without having some kind of a national level agreement between the government and these institutions. And of course, our job would then be to provide them with the ammunition they need to find an agreement with their government. But we have to realize that this is something that will take place at national level. On the other hand, of course, European initiatives like the Open Data Directive, like the high-value data sets that are now being discussed with member states, will of course push this in the right direction, hopefully, in the future. But again, it will be very different from one community to another. Some are simply asked to generate revenue based on data, and therefore they need to find a solution before they can make these data available.
I will to add something also. In Colombia, before 2012, you have to pay for hydrometeorological information. After the law of that year, all information is free, available, and it put challenges to all entities to have some metadata for the information they share to make easily to understand users what you are sharing, and also to maintain some platforms stable to share this information, because it's not just to say resource to provide this information. So it is a good issue, but makes some challenge for entities also. Thank you.
Well, this is perhaps also an obstacle that sharing data is not just sending a file to somewhere. You need really to document the data and explain the data. And I think this is additional work that's usually not paid for. And perhaps one additional aspect is that I'm always seeing this open data as a coin that has two sides. And one is the data provision, the open data provision, but also then still the acknowledgement of the data providers, which could be done through data citation. And I think we are still, and perhaps GEO can help here as well, we are still lacking a culture of acknowledgement of data providers. When it comes to the academic sphere, universities are also public institutions in most of the countries, and there you have when you have an evaluation or a ranking of universities, it's publications, it's something with some indicators with education, but there is no data sharing indicator. So if a university had a high data sharing index, this should somewhere also perhaps be acknowledged in evaluations or assessments. And I think there we also need a change in our culture that open data is not just something that you do, but also something that is acknowledged. Okay, we are slowly coming towards the end of our discussion and our session. I would like to thank all of you again. If you want to have a final comment or a final word, you're welcome. And otherwise, I will hand over to Gilberto, who might speak the final word for closing this GEO week. But as I said, I first want to give you the opportunity to have a final comment or a final word.
Warner, this is James. I would just say, again, a great thank you for GEO, the GEO leadership. It's been a real great experience for me being new into this community of GEO, being a part of the Canberra meeting last year, now being a part of these kind of discussions and this week, and really beginning to understand what might be the opportunities for Indigenous people to really benefit and also contribute to GEO in terms of everything we've talked about today, from open data to education, capacity building, all those important things that we all care about. So there's some things that we do care about and we have in common. So let's continue to provide leadership and practice to do this work well. So thank you, Warner. Good job at facilitating, and to all the participants. Good to meet you, and thank you again for your talks.
And hope to meet you in person next year. And so from my side, I want to say at the end, stay safe, stay healthy, and as I said, let's meet in person next year. And with that, I'm closing this session and give the word to Gilberto.
Werner, thank you so much. So my words, initial words are thanks for a very interesting panel. I've been following the discussion. So James, Fabio, Connor, Henrik, and very much, and Werner, thank you very much for a stimulating discussion. Just to comment on some things that you've just touched, because the discussion has been quite interesting. There is no such thing as too much data. We all agree to that. And one of the issues that the GEO Secretariat has recognized is to increase the visibility of those that share the data. So some of you have asked this issue. The development of the Knowledge Hub is an opportunity to increase the culture of data sharing in our community. So one of the things we have on the Knowledge Hub is that when you deposit a document there, we have an agreement with data sites so that you can get a DOI. So any document can be a piece of software, a data set, a report, a video, a ground observation, a series of pictures of some areas. organized by any of you or your collaborators, will get a citable and unique object identifier, so that when people would use it to cite your work, you are acknowledged as the data producer. So this is very important. We recognize that some of you have raised the issue, and it's absolutely crucial that there is a recognition of those that produce the data for the others. I think, of course, there is a community issue, and I think our community has awakened, I would argue, to the problem. Other communities are really pushing strongly in this area. The health community with COVID made it clear that you cannot just send a paper to Lancet or to British Medical Journal without providing the data. People are just simply not accepting it because, of course, this is now has consequences in practices. And therefore, we hope that the same kind of, let's say, societal benefits and societal consequences of course, an estimate of water availability in a country or population growth or food security should carry out the responsibility to share the data of those who issue this kind of report. That's, I mean, we could go on, of course, given that GEO's mandate is to bring the data, this discussion could go on and on. So for now, I would have to say I loved the discussion. It was really very, very, very insightful. And thank you for making such a good panel. On that, I would also like to close the GEO Week and make some acknowledgements of those that participated, like you, but those that participated in the other sessions. The executive committee who ran a meeting last week. We had the awards committee, which handled the awards, those that organized the industry track, those that organized the panel in this morning, and the panels for the community yesterday. So there's a huge mobilization of dozens of people who have given their time for an ideal. And I think this is fantastic. If you think about it, all of you and many of you are just giving your time for something you believe in, which is a better planet and a better world. And this is in a world where we see so much violence, where we see so much, self-interested, and we see so much people just looking at their own navel. You have people who still want to give up their time to, fight for a better planet. And I think I would like to specifically thank the indigenous communities here, James and all his team, because this is inspiring for us. It's communities that have lived closer to nature in a much more bigger respect to nature than we have. So in that respect, it's us that have to do some capacity development on this area, not you that have to develop capacity development. We are the ones who have to learn a lot from you. So I think it's encouraging. If we should never let our hope go down, because the fact that you are here, the fact that there is a community, the fact that a lot of this work is voluntary and done for the good is inspiring for us and for the next generations. So it's an honor to be the Secretary Director, but I think it's more important thing, it's an honor to have you. You are the ones who are pushing this, and all of those that participate in GEO. And you can be sure that we are working together for a common good. And this cannot be a parting thought so encouraging and so hopeful for the tough times we live. Thank you very much for all. Thank you that have attended. And let's see, next year, Port Elizabeth, in person. Thank you so much. Have a good day, good night, good evening. Pleasure.
Bye.
Bye-bye.
Bye-bye.